Good day, everybody. How are you all? Today we are going to do a hypothesis test for population proportion, but we will use the concept of confidence interval. So I'll share my screen with you. Okay. So it should be at least 60% of graduate students have assistantship to pay for education. A college dean thinks this percentage is too high. She randomly selects 50 graduate students and finds that 26 have assistantship. At alpha equal to 0.05, is the dean's assertion correct? Okay. So in this case, the null hypothesis, if you have watched my earlier video from yesterday, you know the null hypothesis, which is the null H sub 0, is P equal to, we always use equal to sign in the null hypothesis, 0.6, and the alternate H sub A is P less than 0.6, because that's what the dean asserts, that that number proportion is too high. So first, let's calculate the sample proportion. Sample proportion is P hat, okay? And that is equal to X over N. So what is X? X divided by N. X is your number of success. Number of success. And N is your sample size. Sample size. So in our case, the problem as it states sample proportion is equal to X, in this case, number of success, 26 have assistantship out of sample size of 50. Okay. And that's 26 divided by, it should be 26 divided by 50. And that's 0.52. So notice my X number of successes is 26 and my sample size is 50. Okay. So my number of failures is equal to 50 minus 26. 50 minus 26, which is 24. Both number of successes and number of failures are greater than 10. What does it mean? It means we can assume that the sampling distribution, assume that the sampling distribution of P hat is normal. Sampling distribution of P hat is normal, of P hat, that is sample proportion is normal of P hat. So this is P hat is normal. Okay. So, and mean of the sampling distribution. So mean of sampling distribution is equal to P population proportion. and is equal to P. Is equal to P. So in our case, that is equal to hypothesized population proportion, which is equal to 0.6. Okay. And our sampling standard deviation of the sampling distribution, deviation of the sampling distribution of the sampling distribution, which is given by this formula, is square root P times 1 minus P divided by N. Okay. P times 1 minus P divided by N. Okay. That is the standard deviation of the sampling distribution. And in our case, this is equal to SQ. Root is the square root. Then P, my P is the hypothesized population proportion is 0.6. Then I multiply that with, multiply that with 1 minus 0.6. P0, the hypothesized population proportion is 0.6. So it is 0.6 times 1 minus 0.6 divided by the sample size. So divided by N, my sample size is 50. So that's my, not 550, it's just 50. And that's my standard deviation of the sampling distribution. Okay. And that's 0.069282. Now, remember level of significance, that is alpha is equal to 0.05, and that is equal to maximum probability of rejecting H0 when it is true. Okay. So our level of confidence, which is the complement of the level of significance. So level of confidence is C is equal to 1 minus alpha. And 1 minus alpha. So I got to write the P correctly. Okay. And that is equal to 1 minus 0.05, which is 95% confidence. So we will use the formula for the confidence interval, 95% confidence interval for the population proportion. Okay. So for that, we can calculate the margin of error, which is equal to critical value, Z critical value for 95%, Z critical value times multiplied by standard deviation of sampling distribution. So that is equal to distribution, and that is distribution. And that in our case is equal to, for 95% confidence, is equal to 1.96 times the standard deviation that we have already calculated, which is 0.069282, 0.0693, you might say. Okay. Yeah. Okay, so let's calculate that margin of error, and that is equal to the 1.96 is the critical value of Z for 95% confidence level. That is multiplied by standard deviation of the sampling distribution, which is 0.0693. So equal to 1.96 times multiplied by this symbol 0.0693, and that works out to 0.135. So the lower boundary of 95% confidence interval is P hat minus margin of error, okay, and that is equal to P hat minus lower boundary of 95% P hat minus margin of error, okay. So that will be equal to P hat, my P hat I've calculated in cell D7, okay, equal to D D7 minus my margin of error, which I have calculated in cell J18. Okay, so this is the lower boundary, and the upper boundary of 95% confidence interval, 95% confidence interval, okay, interval is P hat minus plus the margin of margin of error, plus the margin of error, okay, plus the margin of error, no, P. So let's write it from the, so upper boundary of 95, upper boundary of 95% confidence interval is equal to is P hat plus margin of error. So again, it will be P hat is in cell D7 equal to D7 and plus. Now we are doing the upper boundary, so plus the margin of error, which in cell J18. Okay. So the 95% confidence interval for P can be written as between 0.384. It starts at 0.384, that is the lower boundary, and the upper boundary is 656, you might say. So notice hypothesized value of P0, okay, equal to 0.6 equal to 0.6 is inside this interval, is inside the 95% confidence interval. 95% confidence interval. Since this hypothesized value is inside the 95% confidence interval, okay, therefore, do not reject the H0. Do not reject H0. Okay, because the hypothesized value of this P equal to 0.06 is the hypothesized value, P0, okay? And this P0 is inside my 95% confidence interval, okay, P0, okay, let me make it 0 with this. Okay, P0, okay. So the hypothesized value of P0, okay, is inside of 0.6, okay? 0.6 is inside the 95% confidence interval. So our decision is do not, therefore, decision is do not reject H0. Do not reject H0. Reject H0. If we do not reject H0, of course, then we do not support the alternate also. So conclusion is at alpha, conclusion at alpha, conclusion is at alpha equal to level of significance, right? Alpha equal to 0.05. 0.05. There is not enough evidence to support HA. Enough evidence to support HA. So summarizing what I did, last time we did the hypothesis test by calculating test statistic and then calculating the probability of getting a test statistic as extreme as what we have calculated or more extreme. And that p-value is greater, that probability value is greater than level of significance. Here, on the other hand, we know the level of significance, the confidence level is complement of level of significance, so 1 minus level of significance, which is 0.95. Then we calculated the 95% confidence interval for population proportion. And that interval, inside that interval lies 0.6, which is the hypothesized value P0 in the null hypothesis. Since it falls right inside the confidence interval, we do not reject the null hypothesis. And therefore, at alpha equal to 0.05, there is not enough evidence to support H sub A alternate. So that is another way of doing the same problem, to calculate the confidence interval and show that the hypothesized value falls inside the confidence interval. Therefore, we do not reject the null hypothesis at the alpha value, okay? And therefore, we do not support the alternate hypothesis. So this is another way of doing this. If you like this video, please share with your friends. If you have any question or comment, write me a note. I'll get back to you as soon as possible. If you like this video, please give me a thumbs up. I appreciate that. Please watch the video until the end, because then you'll know how we can do this hypothesis test in a different way by calculating the confidence interval for the population proportion. Okay, so you and your friends, please subscribe to my channel by hitting the red subscribe button at the bottom right corner. And I will be back next time with another interesting problem, interesting solution. Okay. Take care. Have a nice day. Thanks for watching.